Between the numbers 1 and 2, how many other numbers actually exist? The honest answer is infinitely many. And by the end of this video, you'll see exactly why, plus meet a whole family of numbers that refuse to be written as a fraction at all. A rational number is any number you can write as p over q, where p and q are integers and q is never 0. This single definition actually swallows up everything we've met so far. Even a plain integer like 5 counts, since it's just 5 over 1. Rational numbers also don't have one unique look. -1/3, -2/6, and -3/9 are all the same number, just written differently. We call these equivalent fractions. To place a rational number like 3/4 on the number line, split the gap between 0 and 1 into 4 equal parts, then move 3 of them across. Here's the genuinely magical part. Between any two rational numbers, no matter how close together, there's always another one hiding in between. Just average the two. Average 1 and 3/2, and you get 5/4 sitting right between them. Repeat that forever, and you realize there are infinitely many rational numbers between any 2 points. This property is called density. So do rational numbers fill the entire number line with no gaps at all? No. And here's the proof. Take a square with sides exactly 1 unit long. By Pythagoras, its diagonal squared is 1 squared plus 1 squared, which is 2, so the diagonal itself is the square root of 2. It's provable. By assuming root 2 is a fraction p over q in lowest terms, squaring both sides, and showing p and q would both have to be even, contradicting lowest terms from the start. That contradiction means the assumption was false. Root 2 cannot be written as a fraction. Numbers like this are called irrational numbers. Combine every rational number with every irrational number, and you get the complete gap-free real number line. The easiest way to tell rational from irrational is to just look at the decimal. A rational number's decimal either terminates completely, like 3/8 equals 0.375, or repeats forever in a block, like 5/11 equals 0.454545 repeating. An irrational number's decimal does neither. It goes on forever with no repeating pattern at all, like root 2 equals 1.41422135. With digits that never settle into a loop. You can even convert a repeating decimal back into a fraction. Say x or 0.6 repeating. Multiply both sides by 10 to shift one full repeating block, 10x or 6.6 repeating. Subtract the original equation from this one and the repeating tails cancel out perfectly. 10x, x or 6.6 minus 0.6, so 9x or 6, giving x or 6 over 9, which simplifies to 2/3. Same trick works for any repeating decimal. Shift by a power of 10, matching the repeating block length, subtract, and solve. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. Every 0.375 stops after 3 digits. It terminates, so it's a rational number. The answer is rational. Rational numbers are dense, infinitely many between any 2 points. Yet irrational numbers like root 2 prove real gaps still exist, and together they build the complete real number line. Decimals give away which is which. Terminating or repeating means rational, never repeating means irrational. Free notes in the description. Subscribe to Clarix for the rest of Class 9 Maths.